Okay, but last time we were talking about the general reactions that you're gonna do. We know what's the shortcut. Mechanism-wise, we also know it as well, but again, you're not gonna get tested on the mechanism exactly. And we were talking about IUPAC. What was the ending to name esters? We did this last time.
And now, right? Oh, wait.
OH, exactly. It's OH. What about ketones? Owen, aldehydes? Great job. Okay, so we were talking about the cyclic structures, cyclic esters and cyclic amides. They have a special functional name, which is just either lactones or lactames. We know how to name them. They were pretty simple. We just have a few options. And then again, remember, you're not going to get any questions with substituents sticking out of the ring. So it's going to be very simple. But you might get a question like this, asking for which of the following molecules is going to form a specific type of lactone or lactame. Now, we didn't really talk about those guys. So now let's see how to make them. Okay.
He went over it in class, though.
So that means that you guys should remember. I hope so.
Can we go over that?
What do you mean?
He went over the intramolecular in producing lactone.
Do you want to show me the mechanism?
I guess, sure.
Okay,
I could give it a shot.
give it a try.
So this OH, right? So then you're benzene.
Your base deprotonase that alcohol group. We have that. O minus, beautiful.
Yes. Here. So that's gonna be a methyl right there. That looks about right. I don't know.
You got it. And what's the name of that lactone?
It's a gamma.
It's gamma lactone, and that's it. Great job, Juan.
So that
You got it.
answers the previous question.
Thank you. Okay. It's a pretty simple reaction. So pretty much is acid-base reaction and then nucleophilic attack. More specifically, it's the nucleophilic attack that we learned in this chapter. But actually, this reaction looks somewhat similar to what other reaction that we learned in chapter 12.
Chapter 12, always chapter 12.
It's always chapter 12, yeah. It looks familiar to what reaction? It was intermolecular as well.
We're just gonna start naming them. Friedel crap.
That's 15.
I'm just gonna start naming.
It sounds like your professor.
Oh yeah.
Exactly. It's the West reaction because it also started with an acid-base reaction and then a nucleophilic attack. But this time we had a carbonyl group, an acyl group instead. That was the only main difference. Okay. Questions on how to make your lactones? We're good?
Yeah, you can move on,
but keep it. Okay. Okay. And now, how to break them? We actually already know that. Again, from chapter 12, reductions. Everything is coming back at this point. Do you guys remember the reductions, the mechanism? Exactly, the sodium and the lithium reagent. Do you remember the mechanism?
The sodium was the weaker one that can't reduce esters, but they can reduce, was it carboxylic acid or was it, or either something?
Backwards. Tertiary, no. Secondary, yes. Yes.
Did you write out whatever?
Yes, but actually
This fall,
volunteer to show me the mechanism for this one. Anyway,
Okay, I figured.
I think you know it, Emily. Okay, show me the shortcut. Show me what the product is gonna be.
What's going on with you, brother? The next class, is it right after this? No, I was just. We covered a lot of
ketone?
new stuff, but.
It's an ester.
This isn't for SI.
Oh, that's strong.
This is just for
Exactly.
making
The lithium radiant can work with
So it
everything.
Is for us. Yes. Also, I don't think, no, that's. Is this chapter 17?
Yes, but it's
Did
bringing
you-
back 12. It's bringing back 12.
No, but I'm like the sheet.
Yes, 17.
So is it on Canvas?
I think I posted it last session. No, not sure though. It is gonna break it. Mhm.
No, that picture that posted was the week that I was.
Which O is gonna take you.
I know what you want before, bro, I'm looking at that, that was after the 2 line.
At the very end, yes, because that guy is gonna turn into an alcohol group.
So then this one,
I just barely passed that.
if that takes an age, then maybe,
2 miles an hour.
oh wait, so this one, like that?
Not quite. How do you think the product is gonna look like? Best guess.
So it'll be a perm, some type of
Forties,
perm.
honestly, and just.
I just
Permanent?
jogged.
Try to-
Show me.
I just jogged.
You was worried
Just
about
try it.
that.
Just try it out.
Yeah, like, I was just trying to pay for all of it.
I wouldn't go down with her in like 8 or 9 months. I would try and get it done faster.
That's fast, bro, that's
That's really not that bad.
9 miles an hour.
You ever hit 12, 15?
That
That's
gets
fucking
fast. Yeah, that's, Usain Bolt, max speed is 20.
So you have the right amount of carbons and the right amount of oxygens,
And after 13.
but not quite the connection.
Oh, yeah, not fast. We're big boys, bro. Stick to the weight.
But still, that was really close. So still, great job, Emily.
So the other.
Okay.
Oh, okay.
Do you guys remember the mechanism?
340 dead.
Yeah, that's like the max.
Reductions.
That's what I'm saying, that's what I'm saying. It's the.
Not at all.
That's the ball.
We don't remember reductions at all.
Yeah.
Nothing.
But I guess I don't remember the mechanism. Once you do it, I'll see it.
Okay. Exactly. Yes. You put them a little too close together. But yeah. Okay, let's go through this reduction. Okay, so what's gonna be the nucleophilic agent?
I know that's the electrophile. So then it's lithium, aluminum,
Hydrogen from where? We're gonna grab whatever hydrogen was provided there. And this is the one that's gonna do the nucleophilic attack. It connects to my carbon in here, which makes it sp3 now, because I have to kick up the electrons. So at this point, I have O minus connected to a hydrogen. So far, questions. So far, we're good. Pretty simple. We're starting to remember this a little bit. Okay, that's good. Oh, and this is a hydrogen. Okay, what do we think is gonna happen now?
Oh, it's gonna get protein from the water?
So that can happen, yes, but that's not gonna give me my final product. So Emily, you were more close to the answer. So your electrons are gonna go back down to reform that, and that's how we're finally able to kick that out. So we can break that chain open again. And actually, let's label the carbons.
You zoom out so I can see the initial.
Yes. Am I just gonna protonate it at this point and that's it? What's gonna happen? What was the whole goal of reduction? Exactly. So that means that our hydrogen is gonna come back, do the same attack, so we can get rid of all of the pi electrons that we see in there. And now we have this guy. Do we see it? Okay. Now at this point, your solvent, which is gonna be water, is just gonna protonate them. And that's it. So we end up with 2 primary alcohols in there. Questions?
Where's that other hydride coming from?
The orange one,
Yes.
basically you're just supposed to assume that you have excess of your reducing agent. Because
Oh,
lithium is
excess,
so
okay.
strong. That you
This is
have
on
to,
Chapter 17.
this one, I added a new page.
Okay, so
So-
that's-
Oh, he was asking for it. Okay. Questions so far on how to make and how to break them. Now, same process is gonna happen with your nitrogen, same exact mechanism, okay? So if he changed that oxygen for a nitrogen, don't get scared, it's the same exact thing. So going back to our little question in here. Take 5 minutes. Which of those molecules is gonna give you the gamma lactone? And the other answer choices, what are they gonna yield? What are they gonna form? Alpha, beta, gamma, delta.
Well, it's maybe molecular. Correct. That's right. Yeah. We just went over the mechanism for the previous. You will-
Oh, sorry, Michi. That one was delta. That's game.
Did you pick the paper receipt? Looking the wrong way. Hello, just want to make sure I got the structure.
Oh.
Okay, I have one vote for B. Emily? A? A as well? What about over here? Do we have any guesses?
I can't guess. I need to, but it's taking me a minute to draw these up. For a 50-minute test, something like this.
No, you would actually just remember the mechanism and then see wherever the O's are and the place where.
I mean, I guess that kind of makes sense.
Lactone
Yeah, I took my-
is.
I took
Nah,
my
but
next
bro,
time.
if you're not super
I don't know
comfortable
what
with it,
it
you're
is.
gonna have to draw.
We don't know.
Yeah.
Okay, let's take
The
2 more
Y-lax
minutes.
Structure kind of looks like.
Hmm?
The Y-lax.
Yeah, I just see one.
Feel B, guys.
You think it's B?
For vibes, but yeah.
Any more votes?
Pause.
Yeah. That's, no.
Okay, so. Be in trouble like.
Wait, okay.
No, it's not, it's not.
I get it, I get it. So,
I'm just gonna,
It's
yeah,
A,
I'm gonna go for
it's
A, yeah.
Wait, no, it might be B, no.
It's-
No, listen,
It's A.
it's
It's
A, B,
it's A.
B.
I know it's B.
I'm going for A.
I'm thinking A, thinking A.
I think it's.
We think it's B, B, A.
Definitely not C or, it's definitely not C.
Those of you who said A, you guys are absolutely correct. It is gonna be A. Why?
It's the amount of carbons, are correct in the sense that,
For the cyclic structure?
yeah,
Okay, can you draw the molecules in bond line?
what lactone is a 6-membered.
No, lactone is a cyclic ester.
Yes.
I understand it's a cyclic ester, but it has like 4 carbons and 2 oxygens, right? 6 members.
No, it has nothing to do with the amount.
It depends.
So look at the lactone on the first thing, right?
Gotcha.
Right? So it's alpha position, beta, gamma, delta,
All right.
right? And
It
then
depends.
you just have your examples over there. So it's asking for the gamma.
Gotcha, nice.
I have.
Draw them out, Emily.
Yeah.
No, but it's actually.
And then tell me what each of those answer choices is gonna give you. Best guess.
Lactone.
Best.
Which one's the Y-lax?
Gamma.
Gamma,
Mm,
so that's a 3 member? 4.
You got it.
Okay, alpha, beta, gamma's the 5-member thing, sorry, 5 member, gamma's 5.
I don't think of it like that. Because it's like,
It just works for me like that, 'cause alpha is the most basic, you got the 3-membered ring, beta,
so you have the
Why?
carbon carbon, you don't count that.
Wait until we draw
You
them.
count the first.
No,
alpha,
1 second.
Beta.
Yes. Sorry, Valerie.
But pretty much what you're doing is you're counting the amount of
You do
carbons in
alpha,
between
the first
the oxygen
one,
and then the other
one
oxygen. So this
Mhm.
would be
Who's got the
Gamma,
iPhone?
and then
Is that you?
with that.
A has one,
I
you're
got it.
missing 1 carbon. On the left side, so you see how it's.
Sorry again,
OH
Valerie.
On the left, so it's 1 more carbon and then the OH.
That one. Mm-hmm.
Yep.
Okay, so we know that option A is gonna give you the gamma lactone. What about option B?
Right, cause then that acyl halide. then alpha, beta, gamma, delta. That'll be delta. Beta. Professor, oh, you're in the process.
What is that?
He said you're not really gonna see, alpha, lactose,
Yeah,
cause it just,
structural.
yeah.
What is option B gonna form? What kind of lactone?
What kind of what?
What kind of lactone?
Oh, what did you say, delta?
1, 2, 3.
Mm-hmm.
Alpha.
B is gonna be a delta one. What about option C?
B is gamma. Wait, no, it's also delta.
That's okay.
C is also delta?
No, it's alpha, beta.
So
Oh, it's
remember
the
that you're
position
not
of the
counting
weight.
every single carbon that you see.
It's
You're
the
only
position
counting the
of the
carbons in
weight.
between alcohol and carbonyl. That's what tells you what kind of lactone you're creating. Exactly, that one's beta. What about the very last one? Alpha, that's
I
it.
just wanted to do classes, like, if they, exist, like, they don't exist.
I don't know the rest of
The alpha ones.
Just a great job. Okay, questions on your lactones or lactames?
So when you,
You're counting the number of carbons in between alcohol group and carbonyl. Yes, because if we go back to the mechanism, that's where we do the connections.
draw that, I'll take a picture of that.
Alright, zoom out a bit.
Zoom out, okay?
That's the, pretty much the mechanism.
Okay.
Alright, now zoom up to the alpha, beta, gamma, delta.
I have a question, what is lactic acid?
Perfect, right there.
Is that within the scope?
Lactic acid,
Lactic acid.
it has a carboxylic acid at some point, but I don't remember the whole structure. Like from memory, no,
I'm gonna let Google.
You're
make
slacking on
better
biochem.
don't say that. Delta, it's the one that looks like this.
Delta is the third one from the frame, so second one.
Oh, that's lactic acid.
Wait, what? Delta. Last one, last one.
Lactic acid.
Oh, sorry, I'm getting.
Just change the symbols for the gamma, for the lactones and everything.
Is there an R and an S?
I think it's,
No, that's
it
actually-
should be the Y,
it's a
or can it
mechanism.
also be that?
Isn't there?
Yeah, what's going on there? Cause we had the symbol wrong for gamma, no.
This guy is gamma because it looks like a Y. The one that looks like this guy, it's delta.
That's what we talked
We have R and S.
that.
Lactic acid.
I think the thing is-
Those guys.
But the
There might
type
be a potential dominant
or
formula,
like
like
just
structurally, but like.
Yeah.
I mean,
This guy is a little weird.
That's gamma. That's. Alpha.
Oh, it's just our lactic acid, and that's lactic.
Okay,
Not my trick question.
questions? We're good? Okay, are we ready to start the reactions now? Maybe not.
No, I think I took a picture of something else.
Okay, let's give it a try. Okay, we actually use the very first one. Because at the end, we know that all of the reactions should be relatively simple and easy because we have the mechanism. Sorry, we have the shortcut. That's the easy portion. So what was the shortcut for this chapter? Amputations, Kayla. Good job. So what are you gonna amputate?
Oh, that's right. Take the ACP out.
Which portion?
Just do this.
Mm-hmm. You're gonna chop off your halogen, in this case, or whatever leaving group you have in there. And then what about your reagent? What do you take away?
So it replaces it with OH.
The hydrogen, because if I just keep that hydrogen in there, that oxygen is gonna end up with a positive charge.
Oh, we're making an ester with the ethanol.
So you basically are just replacing the leaving group that you have in your carbonyl for whatever reagent you were provided, and that's it. Question. Pretty simple, pretty easy.
That's funny.
Is that really what it stands for?
IPA, isopropyl.
How you could ask?
I'm being 100% dead.
Like when you order like a beer and it's IPA, is that like a? Just think it's that extra from black. Oh, that's what makes it definitely.
Okay.
I said isopropyl.
You believe that you were drinking isopropyl alcohol?
Oh, I don't drink.
No.
You don't drink?
You
I
believe
don't
that?
drink.
There's no way.
There's no way you say coffee and stuff if you drink alcohol.
Look, his liver is like healthy, like the healthiest out of all of us, so. Okay, volunteers. I need 2 volunteers.
Just chop off the ACL and, oh no, you're gonna give it.
Oh, yes. Go for it.
Could be right, could be wrong, who knows?
For real, that's just life.
That's like, wait, I'm missing.
Mm. We got a little too many carbons.
Dang it.
Look at the previous reaction. The connection was formed to the heteroatom from your reagent.
But isn't this a carbon right here?
That's a
This
carbon.
Right here?
That's not a carbon.
That's not a carbon, so this is only one carbon,
1 carbon.
so that carbon is here. And then that's all, so yeah.
Flip them. Flip them.
Flip what?
Sulfur has to come first, not the carbon.
Oh, see, that makes.
There
a
you
lot of
go.
sense.
Okay, what about the second one? And what's the name of that functional group?
Oh, no, that's a different IPA.
Yeah.
Which one? It's the thioester.
Okay. So you weren't.
Do the second one?
wrong.
Yep. I grouped them together.
Oh, right. You probably-
Could be right, could be wrong, we don't find out.
I mean, water, it is gonna be one of your byproducts.
Okay, so I think.
Count your carbons. And there you go. Great job, Sam. What's the name of that functional group?
Which one?
The one that you just created?
That one? Oh, it's Esther.
Esther.
Okay.
Okay, choose your volunteer for the next 3 reactions.
Oh, yeah,
Okay.
That meant that.
Her hand shot straight
Yeah.
up, what? You go, girl, go crazy.
Wait, what did you use for the date? We haven't asked, right?
Okay, so, alright.
Because I'm thinking you're probably the O.
So, this HCl is protonating the OH to make it H2O, right? You get H2O. This goes. And then,
So it becomes a leaving group, so
Yeah.
it's just.
And then you-
positive.
It doesn't matter. It's equally substituted.
dissociate. Goes away.
Yeah, yeah, I
And
get
then it gets taken up by the CL, which already protonated that. Then I got HCl again, free floating. And then this negative charge,
Oh,
positive
so-
charge here, and go there, dumping bundle.
But the thing about-
Uh,
What's the thing about-
Yes, and what's the byproduct?
There's a byproduct.
There's a hello product and there's a byproduct.
That ass for yourself.
Me and playing COD.
You're correct,
Right?
but that oxygen is gonna have a negative charge. How are you gonna make it happy?
The end. to the-
No,
Wait, how many?
you don't want the negative charge. How are you gonna make it neutral? You have to make it happy.
Oh,
See that?
I see.
I said when it's an un to a carbon, that's a carbonyl, that's
And there you go. Great job, Abigail. Keep going with the reactions.
Wait, no, it's not an amide, it's not an NH. Is that an amide?
The reagent or the product?
the product.
Product amide with a D.
Okay, so
Okay,
it's,
yeah, you're right. So it doesn't have to have H's on it for it to be an amide.
no, it does have an H, look,
It-
it's two single bonds, right?
It needs to
Oh,
have
yeah,
a
it does have an
nitrogen.
H, does have, I didn't count.
Wait, no, but I think you have to explicitly write the H out on a nitrogen.
Abigail, on the previous one, on that nitrogen, just add one more hydrogen
One more height to the.
to the nitrogen. On the
Like,
product,
come on.
just add one hydrogen.
One height.
You take one hydrogen, but that means that there's still one remaining in there. And there you go.
Would it still be an amide if there were three bonds not that one?
Yes. It's still an
Still an
amide. Do you guys need the mechanisms?
Always.
Always? Okay, I'll work on it today then. It's okay. It's okay. I'll show you the mechanism.
Can you kind of scroll just a little bit?
Or yeah, just take a picture.
There you go, perfect.
That works. Pictures are great.
Oh, it kicks off one of these. And, okay.
And
Wait,
there you
first
go.
one is
So for the first step and leaving off the ether, that second bottom one, right there.
Okay.
What initiates the cleaving of the methyl NO? Is it the HCl?
So, okay. So from chapter 16, we learn what acids and bases do to the reaction. What do acids do?
Catalyze, make the electrophile.
Exactly. So what's gonna happen mechanism wise?
The HCl protonates the O,
The oxygen where?
on the methyl. With the,
On the electrophile, which would be the ester.
which would be the ether.
Which portion? Which oxygen
Oh, the
specifically?
top
carbonyl.
The top one, exactly.
Carbonyl.
So that
Oh.
one's gonna gain a
Because
hydrogen
then
in
it
a
gains-
positive
it has a
charge.
positive
And
charge.
then we do the nucleophilic attack. So the carbon in there. And that's how we trigger the whole attack. Questions? For that one? Oh, that's cute. Technically, yes, you do have a byproduct, which is just gonna be methanol. So one carbon, one alcohol group, and that's it. Okay, yeah, you got it. Great job. What's the name of the second product that you created? Yes. The name of the functional group.
The name of the function.
Yes,
Oh,
right next to the heart. Do not say it.
Wait, no,
for
wait,
Abigail.
first off, which one, the second one or the?
The one right next to the heart,
Yeah,
the blue
okay.
one. Nope,
Oh, the one next to the heart?
no, Sam, no. Abigail, you know it. Do not say it. Look back at your notes. Look back at your notes. That's okay. I want you to tell me the name No. from this one. 17.
It deals with reactivity, remember those?
That was the very beginning of this handout.
You're right.
Beautiful. It's your acetic anhydride. And that's it. That was one of the new ones. And great job, Abigail. Acetic anhydride.
Right, so if you take the ethyl group, that is the.
There we go.
acetic anhydride.
Gotcha.
Okay. Let's group these ones. Okay, Abigail?
Can you move up real quick?
Yes.
What's above that?
You can choose a volunteer for the next 3 problems. Anyone you want.
Yeah, I don't wanna rewrite that. I just wrote that right there.
I'm just kidding. I didn't read that.
Okay, we're ready?
You ready?
We choose Kayla.
I chose.
Kayla's not too excited.
Oh,
My,
we're just,
my,
yeah, okay,
my,
okay.
my energy came out, sorry.
I don't
What?
It's a cute Pokemon though.
Oh, no, no idea.
That's not-
Mm-mm.
no. Oh, Snivel.
Nope, not clicking. You have to show me.
Any video game?
No, my brother does. Brother and boyfriend, yeah, they do. Me, they tried. I can't.
You play Call of Duty?
No, I can't with Minecraft.
I thought
It's so boring for me.
Boring.
It's boring for me. Yeah. What?
You're so bad.
Wait, she's trying to say something. What? I don't play any video games, guys. Like, so if you say any games, like, I'm just gonna say no.
Yeah.
No, for real, like, if you ever heard of the
It's
Anthem
not the
servers?
Is it making potions?
Mm.
Yo, somebody get her gamer tag, bro.
So far, you're good.
Funny, I get that. It's like, there's a heavy screen, you know.
Just show me product. Just show me the product. No by product. Main product. That's it. And great job.
Even the chemicals are telling us to shut up. See how it says.
Yo, you're tripping.
What about the last one?
Oh, my trip, and I'm just
I would
making
love
an
to be in-
astute observation.
I would love to be in a Call of Duty line.
And you already said that.
No, I have genetics, I got this, I got that. I believe you got two nieces that be sleeping over every weekend.
Pretty much, like, no, but my sleeping.
And yes, you're correct.
Really?
Yes, you got it, Kayla. What's the name of the middle one?
Middle one?
Yes, the product that you created.
Yeah, no, I'm not babysitting until that takes place.
Bioester, beautiful. Bioester. Okay, Kayla, choose your volunteer.
Somebody wanna do it?
Your mother.
We're doing vegetarian.
That was you, dog.
Back to Sam.
No, you made it some cod lobbies. You know what I'm saying? I could this hysterically hindered, okay. No, you keep going, you're still good, you're still good.
Is it like,
No.
Um,
Not really.
so this associated, we got. this
Yep.
portion. Does it attach O first or nothing first? But that's what I'm saying, there's a reason. Oh, I'm done, I keep wrong.
Wait, why?
Am I cleaving here? Am I cleaving?
No, it would make sense for you to cleave to the least hysterically hindered side, I don't know.
you can cleave both sides. Doesn't really matter.
But there's a predominant, there's a majority.
Yeah, the least hysterically hindered is easier to attack. So the right one. So you were initially correct.
So this one?
No, yeah, so you're good, that's what I'm saying, cause it's least hysterically hindered.
And then when you
Yeah,
start
that's what I'm
drawing it, you
thinking.
were
I'm
good.
thinking, where does the O attach to?
No, here.
Go ahead, go crazy.
Go crazy.
Why is it brown? Like, I like the red one.
Choose the red one. You can change it.
It was the funny
You looked at his arms.
What? To the carbon, yeah.
You make this.
That's one of them?
Are we gonna draw the transition?
then boom. No, that's not the transition phase.
Great
that's
job,
just it.
Juan. You got it.
You see what I'm saying?
That's
'Cause you-
actually.
That's the
yeah.
byproduct.
Oh, so you just cap it off with H?
Yeah, pretty much, like, cause you see the HCl,
Uh-huh.
right, it's just gonna protonate because when you cleave it, just boom.
And then you're getting HCl again because that little ethanol is protonating HCl. Alright, so you know why.
Sam, keep going. Because technically it's easier to attack that carbonyl that's less directly hindered, but you can create both products at the same time.
Stuff.
Great job. And very last one. And yes, HCl. It's not too bad.
Am I
Exactly.
getting-
Well, we're still
Not
gonna
too
do a
bad.
review, right?
I'm
Oh
getting.
my God. I'll make your review handout. Don't worry about it.
I'm feeding that side, correct? That's the correct.
Very, very well.
Not there. It is.
It is there.
Is there?
Yes. Because you always cleave that connection
Oh,
between
'cause you're
carbonyl
protonating
and
this,
leaving
so
group.
it Activates on that, okay.
Uh-huh.
You're not?
No, yes, you're
Oh, no,
correct.
no,
Keep
everything
going,
is
keep going.
correct.
Trust your gut.
Draw that positive card.
And that's that.
Oh,
No,
No.
no. You start with a cyclic ester.
You started with a cyclic ester.
So that means that once you cleave it open, everything is hanging from the same molecule. So that oxygen from your leaving group, where is it?
oh, I see what you're saying.
Where's the little oxygen?
Isn't that the oxygen that was?
No, listen, just imagine that bond between, you know that ester? Imagine that bond's not there, right? And then unravel. Where you cleave it, right?
Yeah,
Bond,
this was cleaved.
right? So then unravel it.
Ooh, okay, I see.
They're missing one little OH.
This is supposed to be on this side.
No, no, no. You were good, Sam. You're good.
So what am I missing?
A little OH on the right side. Because that oxygen in there, it's hanging from the same structure, so it's still there. At the end, we just protonated and that's how we end up.
Goes away, that becomes this. This.
Great job, you got it. There you go.
Oh, okay, yeah.
Mhm.
Okay.
You got it, Sam. What's the name of that functional group?
I promise you
We just said it.
Anhydride.
Okay, what about it?
Acetic anhydride, yes. Okay, Sam, you know the drill. Choose your volunteer.
Alright, he's looking.
Isn't, what's it called? Vinegar acetic anhydride, or just acetic acid, right?
It's acetic acid. Can you zoom out a little bit? Which portion do you need? That one, okay.
Like low diphthesis, low key.
It's represent.
Just hit, oh, push button.
We clean, get rid of the hydrogen.
I only got a couple reps. So I want to do.
I know your shoulder's feeling funky right now. You have
Yeah.
something for stability?
Like-
Like, no, that's
No,
not,
that's diamond,
pike is, basically, you think a 90 degree. Instead of,
the 90 degree, right, would it be?
Are we
Oh,
doing
I know.
plank?
Oh, that's like that's good.
it's.
Not quite. Not quite. You were correct when you started drawing it. Because that oxygen that you drew that's hanging, that one is just gonna get protonated. So it's gonna be an OH for that one. And on the other end, that's where you touch your sulfur group.
So people.
It actually hurt.
So you know people, right? People in this group, yeah, that was happening and all that.
One more carbon. There you go. And then the oxygen on the left, what is it missing? A little H. Beautiful job.
I saw him going, reading workout.
Sorry?
He was too big to run. He was too big to fucking run.
From the sulfur.
Like, that's the thing, like, if you're too big to run, bro, you're too big.
No,
no, it's not even like that. I'm not hating, listen, that man can be weak. My point is, I'm a functional about it. That man can't.
For this one, try to show me the mechanism. It's the one that we worked on today.
I'm gonna tell you something.
I guess functionality is relative.
It's a little more up.
Couch.
I think it's after the spider web or before the spider web, one of those.
Yeah. Take groceries in one trip.
Sodium goes away.
Get that, goes away, get your molecular, you're making a lactam.
We're gonna deprotonate our alcohol group. So far, so good. It's gonna have a negative charge. There you go. And now nucleophilic attack. Beautiful. There you go.
That's how you form a cycle. How are you gonna form?
Yeah, no.
Intraplate.
Yes, we got it. That's it. Great job. Okay, any questions so far in the reaction?
Yes, all the way up.
All the same. Okay,
Thanks, Papa.
and great job. I'm gonna put the entire page.
Yay. Okay, now zoom in for like top.
Okay, let's do first three there.
All right, that's all I need.
Well, I gotta go to eat two grades. You wanna learn some?
Okay, so we're gonna continue with the handout on Wednesday, and we're probably gonna start reviewing for your exam Wednesday as well. So I'll see you guys in a few days.
Motion is three-dimension, right?
I think up until like physics 2, where you get into electronics and,
You wanna take a picture
electrical potential and all that stuff.
I'll take.
of the top one? There, okay.
Right.
I did not, that's why I'm not. Then again, it's fun, we'll get genetics.
You know, that guy, you are, absolutely.
My grandparents.
Same way.
Yeah, but like that, I think that's.
I need to get my students to work.
No, it's like, I remember, like, my husband, like, I don't know what's going on.
Oh, Naeem.
Naeem.
Yeah.
Have a good one. I remember the next time. They were like, you big ass nose.
That sounds like a stupid question, but what are all of these dragons? Like, what is the generic? Oh, okay. Cause I was like sitting here, I'm like, what is going on?
Yeah, thank you.